So today we are going to discuss how to draw a graph of Newman's projection. Remember that the graph of Newman's projection actually shows us two things, which is energy maxima and energy minima. These are the two things that are shown by graph of the Newman's projection. Now, if we draw a graph, now energy is mentioned here while angles, bond angles are mentioned here. Now remember that this bond angle is actually related to dihedral angle. You must remember the mechanism that whenever there is a single bond between two carbon atoms, let's suppose this is carbon to carbon single bond. This single bond can actually be rotated, which means that these carbon atom can rotate around this single bond, and these hydrogen atom can also show the rotation. So this point in graph actually shows us 0 degrees, and at 0 degrees there will be no rotation. So this point at the graph shows us the 0 degrees, and the next point will be 60 degrees, then 120 degrees, then 180 degrees, then 240 degrees, then 300 degrees, then 360 degrees. So we have assumed the whole rotation of one carbon atom at 360 degrees, which means complete rotation. Now you can imagine that one carbon is rotating while the single carbon is static and is not rotating. So when this carbon atom will rotate, these hydrogen atom will have certain angle with respect to these hydrogen atoms, and it will actually be called as a dihedral angle. And what will be the relationship of energies when it actually shows the rotation? Now we are going to discuss this in the form of graph. So this is the basic thing and main thing about Newman's projection, that you must learn how to draw a graph. So at 0 degrees, let's suppose we are drawing a conformation here, and we are saying that this is our front carbon, while the back carbon is represented by a circle, and I am assuming that this particular conformation is eclipsed. Now, if the two bonds are parallel to each other, I am talking about carbon to hydrogen bond, you can say that there is no angle between them until or unless it shows some sort of rotation. So we will say that at this point, the bond angle, dihedral angle will be 0 degrees. So this kind of conformation will be called as eclipsed conformation. So eclipsed conformation starts from 0 degrees, and at this point, this molecule will be at higher energy state, which means that eclipsed will be less stable. So at higher energy state, the graph will be started from here rather than at 0 point. So we will start a graph from here until or unless it reaches the 60 degrees. Let's suppose these two hydrogen atom, carbon to hydrogen bonds are parallel to each other, and I am going to rotate it at a 60 degrees. So at 60 degrees, this hydrogen atom will be slightly rotated, and we will get this conformation. Now, just rotating one carbon atom, we get our staggered conformation, and this kind of conformation will be staggered. Now, at staggered conformation, remember that the energy will be minimum until or unless it is again rotated to 60 degrees. So we are adding 60 degrees in every rotation. So here we have 60 degrees, and then 120 plus 60 is equal to 180, then plus 60 equal to 240, then plus 60 equal to 300, then 300 plus 60 equal to 360. So at 60 degrees we got the staggered conformation. We have rotated it at a 60 degrees, and it will be the lower energy state of a molecule. Now let's suppose again it is rotated to again another 60 degrees. Then what will happen is that it will be shifted to the higher energy state. So the conformation we will get will be, and these hydrogen will be parallel to this one. So again the state will be eclipsed. So at eclipsed conformation, the molecule is again at higher energy state, and we will draw another rotation of 180 degrees, and we will again get now these two hydrogen atoms will be shifted in between this, and one hydrogen atom here, other here, and okay. So again we have got our staggered conformation where there is a lower energy state of a molecule. Same case, one staggered, another eclipsed, then staggered, then eclipsed will continue until we get 360-degree rotation. So I'm just drawing it. So this will be staggered, and the next state of course will be the eclipsed one. Then we will get again staggered, and the next state will again be eclipsed conformation. Now, every eclipsed conformation will be considered as a higher energy state. So just drawing it a curvature, we can mention their energy states like this. And the graph will end up here at this point of 360. So this is our relationship of bond angles, dihedral angles with relative energies. Every eclipsed conformation, for example, here we have eclipsed, here we have eclipsed, 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 and staggered, staggered, staggered. So we have three staggered conformation and they have passed four eclipsed conformation. So what is the reason that molecule lose its energy? The reason is simple, that in eclipsed conformation there are two factors. One is steric repulsion and the second one is van der Waals repulsion. Now, when these repulsion operates, the molecule actually gets rotated due to the steric repulsion. And when this rotation takes place, the molecule automatically loses its energy to get stability. Now, what will happen that this molecule gets converted into eclipsed again? The reason is that we have to provide energy. So external energy actually render these staggered conformation to get converted into eclipsed conformation again. Now the question arises, from where does this external energy came? This external energy that actually renders this staggered conformation gets converted into eclipsed again to the high energy state. This external energy actually comes from intermolecular collisions. So intermolecular collisions actually work as an external factor to transfer energy. So molecule again come to the staggered conformation, again molecular collision leads to eclipse conformation and staggered and eclipse. So if we provide external temperature, then there are the possibilities that these staggered molecules gets converted into eclipsed form. Now, what are these terms, energy maxima and energy minima? Remember that all those states of higher energies are called as energy maxima, and all those states of lower energy are called as energy minima. So